My greetings to all. I am Sesha Vidya, working as an Associate Professor in the Department of ECE at R.M.K College of Engineering and Technology. Now let's discuss about optical communication. In this session, we are going to discuss about what is optical fiber communication, why optical fiber, and what is the fiber structure, what are the advantages and disadvantages of optical fiber, and types of fibers, and also its applications. Now let's go into optical fiber communication. Optical fiber communication is the method of communication in which the signal is transmitted in the form of light. Here the optical fiber is acting as a medium between transmitter and receiver. Here the signal transmitted in the optical fiber is converted from the electrical signal into light, and at the receiving end it is converted back into the electrical signal. If you look into that picture, at the transmitter side there is an optical source, and at the same time at the receiver side there is an optical detector. The purpose of optical source at the transmitter side is to convert the original electrical signal into light signal, and at the receiving end the purpose of optical detector is to convert that light signal into the original electrical signal. Now we can see the light signal which is transmitting through the optical fiber cable from transmitter to the receiver. Now this picture which represents transmitting of data in the form of light from one place to the another. The data sent can be in the form of audio, video or telemetry data that is to be sent over long distances or over local area networks. Do you know what is an optical fiber? An optical fiber is a flexible, transparent fiber made up of glass or plastic to a diameter slightly thicker than that of human hair. An optical fiber is a cylindric dielectric waveguide that transmits the light along its axis by the process of total internal reflection. So this is how the light signal is transmitted through the optical fiber. Optical fiber uses light pulses instead of electrical pulses to transmit information, thus delivers the hundreds of times higher bandwidth than traditional electrical systems. Why light? Why not electricity? Light is used for the optical fiber communication because of the reason that the light is a single wavelength light source, while the other light signals like sunlight or the bulb which we are using in our house have many wavelengths of light, and as a result, if used for communication, they would produce a beam which is very less powerful. But the laser light having a single beam would result in more powerful beam as output. So less dispersion, transmitting more number of signals and consuming less time makes the light a good source for communication. Now let us see what is optical fiber structure. The fiber consists of a core surrounded by a cladding layer, both of which are made up of dielectric materials. Optical fibers typically include a core surrounded by a transparent cladding material with a lower index of refraction. Light is kept in the core by the phenomena of total internal reflection, which causes the fiber to act as a waveguide. Now, let us watch the video which gives the clear picture of fiber structure.
Structure of an optical fiber. Optical fiber is a thin, flexible medium and is cylindrical in shape. consists of core, cladding, and buffer coating. Core is an inner cylinder which is made up of glass or plastic. It is the light guiding region of the fiber. Cladding is another cylindrical shell which surrounds the core. It is also made up of glass or plastic. The refractive index of cladding is lower than that of core. Therefore, cladding helps to keep the light within the core. And buffer coating is the outermost region of an optical fiber. It is a plastic or polymer coating given to the cladding for protection against moisture, crushing, abrasion, and other environmental hazards.
I hope the video was clear and self-explanatory. Now we are going to discuss about what are the advantages and disadvantages of optical fiber communication. Now let's see the advantages of optical fibers. Large transmission capacity. A single silica fiber can carry thousands of telephone channels utilizing only a small part of the theoretical capacity. Next comes to low attenuation loss. Approximately zero point 0.2 decibel per kilometer signal is lost for modern single mode silica fibers so that many tens of kilometers can be transmitted without amplifying the signals. Third one is easy amplification. A large number of channels can be re-amplified in a single fiber amplifier if required for very large transmission distances. Low cost. Due to the higher data rate, the cost per transported bit can be extremely low. Next comes to lightweight. Compared with the electrical cables, fiber optic cables are very light in weight. High speed. Fiber optic cables have a core that carries light to transmit data. This allows the fiber optic cables to carry signals at speeds that are only about 31% slower than the speed of light, but at the same time faster than that of copper cables. Better reliability. Fiber is immune to temperature changes, severe weather and moisture, all of which can hamper the connectivity of copper cable. Since fiber does not carry electrical current, so it's not bothered by the electromagnetic interference. That is, it will not interrupt the data transmission. Greater bandwidth. Copper cables were originally designed for voice transmission and have a limited bandwidth. But fiber optic cables provide more bandwidth for carrying more data than copper cables of the same diameter. No interference at all. That is, fiber optic cables are immune to problems that arise with electrical cables such as ground loops or electromagnetic interference. Now we can use it for longer distances. Fiber optic cables can carry signals much faster than the typical copper cables. For example, some 10 gigabits per second, single mode fiber cables can carry signals almost 25 miles. The actual distance depends on the type of cable, the wavelength and the network. Let's discuss about what are the types of optical fibers. There are two types of optical fibers based on the materials used. One is glass, other one is plastic. Again, based on the number of modes that the fiber can support, glass optical fibers are classified into two types. One is single mode optical fiber, the other one is multi-mode. Again, the multi-mode optical fibers, based on the refractive index profile, again it is classified into two types. One is step index fiber, the other one is graded index fiber. Let us see what is the difference between single mode fiber and multi-mode fiber. Single mode fiber. Single mode fiber has a smaller core diameter of 8 to 12 micrometer. Look into that picture which represents the smaller core diameter. It allows a single wavelength and pathway for light to travel, which greatly decreases light reflections and lowers the attenuation. Multimode fiber. Multimode optical fiber has larger core diameter than that of a single mode optical fiber cable. This multimode fiber allows multiple pathways and several wavelengths of light to be transmitted. According to the fiber refractive index distribution, multimode fibers, again it is divided into two types. One is step index fiber, other one is graded index fiber. In case of step index fiber, the refractive index profile is uniform throughout the core. But in the case of gradient index fiber, refractive index value is constant only at the axis, but at the same time which is gradually decreases as the radial distance increases. Applications of optical fiber. First one, telephone signal transmission. Optical fibers are used for point-to-point communication between remote stations. Second one, internet communication. This application which plays important role in day-to-day life. Bandwidth up to 10 gigabits, streaming movies in HD, effortless video conferencing with no lagging are also possible only because of internet communication. Third comes to detect nuclear radiations. Optical fibers are also used to detect nuclear radiations. Fourth one, cable television signal transmission. Expanded service can include TV broadcast, HD in some cases, voice over internet protocol, phone service, and security over a single broadband connection. Next, fibers are also extensively used in medical diagnosis, particularly in endoscopes. Optical fibers are also used in military applications for safety and security purpose. Now let's see some latest interesting applications of optical fiber.
I know. Looking at this picture, you would be thinking what it is. Haven't you all dreamt about sleeping under the sky and counting the stars? Do you think it's possible now? Yes, it is. This optical fiber is used here for multiple lightning with different colors which has a mesmerizing effect during night. Frock. Yes, this is a frock made up of optical fiber. Don't you think each and every one wants to shine? Yes, that is possible with this optical fiber. This is a dress which shines in dark. Yes, I know it's costly though. Now, let's move on to the third one, colorful lighting effect given by the optical fiber light lamp. These are some of the applications which we shall see here.
Hope that was interesting. So far we discussed advantages and applications of optical fiber, but it has some disadvantages too. First one is high initial cost. That is, the initial cost of installation or setting of cost is very high compared to all other system. Second comes to difficulty in joining and testing of fiber. Since the optical fibers are of very small size, the fiber joining process is very difficult and also costly. It requires some skilled manpower. Third one, special testing equipment is required. For example, OTDR, which is very expensive. Hope you all understood. Thank you for listening.